Continuing with our previous examples, we are now going to get to the meat of the matter and calculate the p-value. So here we have our two examples, of course. We've already have the question. We found that this was a one-sample z-test for proportions. We have our null hypothesis and our alternate hypothesis. They're one tail, they're both one tail. So now we get to move on to step 3, which is to calculate the probability of these samples actually happening, which is going to require, of course, our sampling distributions, which we know because we have already verified that in step 1, that they are normal distributions. We have our sample proportions. Right. In this one with the Prevnar, right, we have 121 children who experienced appetite loss out of 710. Right. And here we have our polio vaccine, where we have our two samples. In sample 1, we had 33 children out of 200,000. Sample 2, 115 out of 2,000. And being two proportion, right, we're actually interested in the difference of the two samples. Now, the center of the sampling distributions, of course, for the Prevnar, the question really is about 15%. Is the sample significantly different than 15? So our center, our theoretical center for our null hypothesis, right, is that it's 15. Right. For a two-sample test, right, we're seeing what the difference is. Again, based on our null hypothesis, right, the difference should be 0. So that's the center of our sampling distribution. What we'll need to do is dimension out our 3 standard deviations. In order to calculate the standard deviation, we're going to have to go back to our summary page, if you remember, which is this. All right. Now we're talking about proportions. Now for the first one, we have one sample. This is for example A. Now example B is two sample, which is down here. Right. This says for confidence interval. We're not doing confidence intervals. This is for tests of significance. So we're going to be using these. This is our example B. And you'll be able to see those as we calculate them next. Right. Here are those equations. Here's the one sample equation. Right. We plug in our p-value, right, our 1 minus p. We get our sample or our standard deviation. Now here, if you look at the equations, since we have two sample proportions, then we have to calculate a pooled proportion, which is essentially averaging the two. And then we use the pooled proportion in our standard error equation, and we get this very small number. Now we can use these to dimension out our 3 standard deviations. That would look something like this. And once we have that, we can locate our sample proportion. All right, so where is 0.17 in comparison to this distribution? Well, it's right here. It's a little over 1 standard deviation from the center. Now this one, this is our sample difference of proportions. It turns out to be way over to the left, way off the scale that we've dimensioned out, which it turns out to be, I think, 6.5 or almost 7 standard deviations away from the center, which is already telling us a lot about what the probability is going to probably turn out to be. So to calculate these probabilities, right, we're talking about the area. That's the probability that we're going to be calculating, right? it's way over here. It's not even graphed on this curve. And of course, what we're going to be using to find these areas is the normal CDF function. We plug in our values. We have, this is our lower bound. Upper bound, I use 2, which is sort of an arbitrarily large value. 2 is way, way, way over here. And so that should give us a pretty good value for the probability. And same thing over here, where we used the lower bound as an arbitrarily, large to the left value. Here's our upper bound, and we get this really small value for P. And those are our probabilities, which is what we need for step 4 in evaluating or interpreting significance. Now, before we continue too much farther, what I'll do is I'll show you how to calculate these probabilities using our TI-84 calculator. If you hit the Stat button, we've used Calc. That has all the WinReg and everything, and 1var stats and 2var stats. We move over to tests, and here is going to be all kinds of tests. Now we have already identified, we have one sample zTest for proportions. So we have proportions, one sample zTest. It looks like we need number 5, which is the one proportion zTest. It's going to ask us for our P0, which is our center, 0.15. It's going to ask us for the count, which is our 121. It's then going to ask us for n, which in this case is our 710. It's going to ask us what we're trying to test, what's our alternate hypothesis really, which is our proportion is going to be less than, or actually what we want is greater than, oops. So here's our alternate hypothesis. Our proportion is greater than our population proportion. And we can hit calculate. And we have, here's our probability right here, 0.0637. Here we had 0.062. All right, well that's because if you can see, here's our p hat, 0.1704, and of course that continues. Over here we rounded, and so the difference in p-values or probabilities is that round-off error. All right, now if we go over here and look at our 2 sample, we can go over and look for our 2 sample proportion z-test. And I've already loaded these in. All right, we have 33 is the count for our first sample, and this is 20,000. And then our second sample is 115 kids got polio out of, again, the 20,000. We are looking for where the first sample is less than the second sample. That would mean, again, that's if we look at our alternate hypothesis, if we put, add P2 to both sides, it would read P1 less than P2. So that's that one. And we can calculate. And here's our p-value, 7.88, e negative 12. And over here we have 7.8, e negative 12. Right, there's our proportion. it gives you our first sample proportion, which is 1.65 E4. There's the 1.65. P2 is 5.75. There's your 5.75. Oops. It gives us, this is the pooled 3.7 E negative 4. Right? Here's the 3.7 E negative 4. If you actually scroll down, it gives you the two N values as well. And so that's how you use your TID4 to do all of this as well. So now what we can do is continue. We got the p-value. That's one way of doing this. And once we have the p-value, these values down here, we can move on to step 4, which is interpreting significance. But before we do that, I want to show you another way of doing step 3, which is called the critical z-score method. Now, to do this, what we're going to use is this standardized normal curve. Standardized being a mean of 0 and a standard deviation of 1, so it makes it all very easy. Now, for that first Prevnar example, we were using a significance value of 5%, 0.05. So the question is, what's the z-score for 0.05? Well, I'm going to use my inverse norm function, and that's going to give me what's called the critical z-value. All right. And here's the 5% that I plugged into my inverse norm, and I had my mean and standard deviation, and so here's this 5% critical z-value. Now you'll notice that for our Prevnar, we were actually doing a positive one-tailed test, but of course these are symmetric, so 5% on this end, z-score will just be a positive 1.64. Now here's our Prevnar example, and we got our probability. Again, we're not going to be using probability anymore for this method. We're going to be calculating z-score and z-critical. We've already calculated the z-critical, right, which is our significance level. And what we have to do is find our z-score for our 0.17. So, of course, it's the difference between your sample and the mean divided by your standard deviation, z-score of 1.45. And if we look at that on the normal distribution in comparison with our z-critical, it looks like it's just a little bit to the left, which is telling us that here's our significance level. It's not in our significance level. So again, we're going to be able to use this to interpret significance in step 4. Now, this is the z-critical for 5%. The nice thing about using z-scores is that this, of course, never changes. 5% significance level always has this z-score. That's one of the reasons why some people like using z-scores. Now, this was for, as it popped up over here, for the one-tail test. Right, if this never changes for the one-tail 5% significance level, this is a good number to record. And maybe what we should do is also record the two-tail critical z-score, which, if we look at the normal distribution and get our critical scores in the same way, right, each tail now is 0.025 because the 5% gets split. That's what gets used in our inverse norm, right, to find, it's going to be right about here. It's a little less than 2. So that's going to give us this area, which is our significance level. And of course it's symmetric, both positive and negative. So over here, it's going to be our positive 1.96. Something like that. And like I said, these are things that we want to look at, right? We have our 1.96, and usually people record these, and you can always use them.